No one wants a handmade engine block or jet turbine. We want precision things made by machines. Machine tools built our modern world. Our lifestyle wouldn't exist without them. Now, machine tools on Modern Marvels. Simply put, machine tools are power-driven machines of all shapes and sizes, primarily used to create metal parts. Those metal parts might be the steel mold for a plastic automobile headlight. They might be the aluminum supports for a jet airplane body. Or they might be parts to another machine tool. Machine tools have left their legacy, cut, stamped, and shaped into the metal of every imaginable product.
It produces thousands of parts that go into the makeup of various items that we utilize every day. If there's no machine tool, everything would have to be shaped by hand scraped, fitted, or filed into specific shape to fit into mating parts.
All these inventions that came about in the late 19th, early 20th century might not have come about as easily as they had if it were not for machine tools.
Machine tools are, at their core, tools. If you think about a tool like a hand drill, a machine tool takes that drill's process and mechanizes it, and performs it more precisely and more efficiently than a human ever could. The most widely used machine tools today are called machining centers. They perform a host of operations from drilling to milling to boring. A raw block of metal goes in, a finished part comes out. One place where this began was the Cincinnati Screw and Tap Company, founded in 1884 by George Mueller and Fred Holz. Today, the company they started is one of the world's leading machine tool manufacturers.
What we do here in Cincinnati is we design, manufacture, and assemble all of our machine tools built in the United States. This particular machine is called the U5 because it can operate on 5 sides of a part. And these days our customers, in trying to reduce setup, they want to complete a part in one operation. Hence they want to be able to operate on all 5 sides of the part. Typical customers of this kind of machine tool are tool and die manufacturers. The machine would come in and would actually shape the die, for example, in the shape of a door frame for a car. There are 2 Pentium microprocessors running the computer that runs this computer numerical control machine. The computer directs all the operations of the machine tool. There might be up to 50,000 unique tool points all blended together in one motion. You can store literally hundreds of thousands of data points in a machine like this.
Machine tools don't come cheap. This one starts at close to $1 million, and that price can quickly double as features are added. Also building the machine tool business was R.K. LeBlond, which opened in Cincinnati in 1887 with just a handful of employees. Today, it's the Makino Company, one of the largest machine tool manufacturers in the world. Among other things, its tools make precision parts for the space shuttle program.
This is one of the stages of an impeller for the main shuttle engine. What happens is we take 3 of these, stack them together, and together they'll generate about 76,000 horsepower running at 36,000 RPM. This is a turbo pump for the oxygen on the main shuttle engine, and it has the ability to drain a swimming pool, Olympic-sized swimming pool, in 59 seconds.
The part is machined from a solid piece of titanium that can cost as much as $50,000. The machining center cuts it to precise, extremely complex specifications.
It takes about 13 or 14 days straight just to mill this part. So this is probably as difficult as it gets.
Machine tools are really extensions of man's most basic tools, the human hand and the human mind. Primitive forms of machine tools have been around for thousands of years. Crude bracelets were turned as early as 100 BC by the Latin Celts. There are drawings of sword grinders dating back to the Dark Ages. In the 1600s, sawmills and grist mills, early forms of machine tools, were built next to streams and powered by falling water. In the 1680s, Peter the Great collected simple machine tools that could decorate watches and trinkets. But the story of modern machine tools, those strong enough to shape heavy metal, begins with the Industrial Revolution in England in the 1700s. These tools depended upon a new source of power, steam. In 1765, James Watt created a steam engine, dependable enough to power a machine. His engine harnessed the up and down action of the piston and used it to turn a crankshaft, a process called rotary power. Watt's rotating crankshaft would be what powered the first modern machine tools.
The real beauty of the steam engines, at least related to the machine industry, is that you could put a steam engine anywhere. You didn't need a water source. You didn't need a mill run to operate a wheel. You could put a steam engine of any size in your factory and do machining.
It was really an innovation to have a steam engine that could be hooked up almost anywhere. Steam engines, however, were difficult to run. They took a long time to get started. They had to be well lubricated. They were loud. Unfortunately, they were quite dirty. They were surely not safe.
In spite of their shortcomings, within 50 years of Watt's steam engine, all the basic modern machine tools would be invented, most of them powered by steam. Some would be adaptations of earlier woodworking tools. Some would be completely new ideas. The mid-1700s through the early 1900s would be the single greatest period of machine tool invention and design.
We think that we are so far advanced today, and we are so clever and so smart and have so much technology behind us, and yet the early people that devised the first machine tools really were very, very bright individuals. It was a by guess and by golly type of thing that eventually produced something of value. They didn't have the college degrees that are evident today, but by golly, they had a lot of ingenuity and they used it.
Machine tools changed the world by making possible the manufacture of all kinds of goods which prior to the Industrial Revolution had only been within the realm of the wealthy. Suddenly, they could be produced in vast quantities at low cost. The machine tools that made this possible can be broken down into 7 basic types. The earliest are the turning machines, also known as lathes and bores. The second were the planers and shapers, built to work with metal much like a carpenter's plane. Third was the most durable of all machine tools, the milling machine. Like the planer and shaper, it smooths and shapes metal parts. 4 other tools round out the 7: drilling machines, grinders, power saws, and large metal shaping tools known as punch presses. All were invented by men working with little more than intuition and a deadline. When we come back, we'll take a look at them all. The earliest object ever found made by a turning machine was a bowl, discovered in Italy, made in 700 BC. Machine tools will return on Modern Marvels. It is difficult to trace the development of a machine tool in a single clear line. People invented machine tools for their own private use, to make some specific product, never intending to sell them. Also, early machinists were concentrated together. As they visited one another's shops, they saw and borrowed ideas. There was little respect for patents, and laws that protected machine tools were hard to enforce. Still, it is clear that the first modern machine tool to be invented was the turning machine, commonly called a boring machine. Its invention is credited to John Wilkinson, known in the 1760s as the Great Stafford Ironmaster, because of his skill casting iron. Wilkinson had been pouring iron castings since his 20s when he built his first blast furnace. In 1775, realizing it would help to make cannons if he could bore the inside of the rough barrels smooth, he used Watt's steam engine to construct the first boring machine. Other boring machines soon followed. Most were used to make cannons. Weapons were often the first use for machine tools. However, Wilkinson's machine was also used to improve the steam engine by boring larger pistons. Like many machine tools, it improved the machine that had helped give it life. Wilkinson's boring machine was soon followed by a metal cutting lathe.
The lathe is probably the most versatile machine and the most widely used of all the machine tools because so many things are cylindrical in nature, and its primary purpose is to cut metal down to a specific diameter. This is important if you're going to make an axle shaft, for instance, for a wagon so that the wagon wheel would fit on. It's important in the manufacture of any type of automobile parts, transmissions, engines. Virtually everything is basically cylindrical in nature, and this is turned on a lathe.
Wilkinson, however, did not invent the lathe. That fell to another Englishman. Henry Maudsley had apprenticed to the famous lockmaker Joseph Bramah in 1791. Maudsley soon became Bramah's foreman, but when Maudsley was refused a raise, he struck out on his own. In 1797, inspired by the early wooden lathes, Maudsley created the first metal lathe. It was used to cut screws. In the early 1800s, an American named Tom Blanchard created a new kind of lathe to machine heavy wood gun stocks. It was called a pattern lathe.
He would put in essentially a pattern piece in the top of the machine, and the lathe would follow this pattern to create another identical gun stock in 20-25 minutes. It was this type of machining that they were going for, especially in the firearms industry, where you could pump out these pieces and then assemble them.
Lathes became the focus of early productivity experts. Their handles were moved to one side so machinists wouldn't have to walk around them. In 1845, Stephen Fitch of Middlefield, Connecticut, built the first turret lathe, in which several tools could be held and rotated as the cutting progressed. In 1887, the R.K. LeBlond Company opened in Cincinnati, Ohio, a city that would become famous for machine tool manufacturing. LeBlond would become the largest manufacturer of lathes in the world.
This is a 1903 R.K. LeBlond lathe. It's manufactured here in Cincinnati. The lathe is the oldest form of all machine tools. The idea of actually turning an object to shape it into a round shape or a smoother round shape goes back millennia, even to the time of the first wheels.
Two critical aspects of all lathes are their speed, the rate at which the stock turns, and their feed, how fast the tool is moved as it cuts.
The speed of the lathe is controlled by the pulley size, which is set on the lathe itself. The smaller the pulley wheel that it's set on the lathe, the faster, the higher the RPMs. The larger, the slower. There's another pulley wheel system which controls the feed rate, the rate that the tool moves either one direction or another on the stock that's being worked.
While their power has evolved from steam to diesel and now electric, lathes still look much the same as they did 100 years ago.
You can make a machine tool faster, you can make them more accurate, you can make them more precise, but the principles behind cutting, shaping, and finishing a piece of metal have remained the same.
The principles may have remained the same, but lathes did grow in size. the spindles on some reaching over 40 feet. And as with all machine tools, they were at their busiest during both world wars.
As far as the Arcade LeBlanc Company is concerned, they had a tremendous role in World War I and World War II. They produced what we call a gun boring lathe for the various artillery pieces that were used throughout the war. The big howitzers.
Many believe World War II could not have been won without American machine tools.
Without the quality of machines that we had, which produced quality parts, we never could have provided the war material for England, France, and the Australians, the Canadians. They all used American equipment. I think they made the difference between our winning the war or possibly losing the war. If we had not been able to supply virtually the rest of the world with the necessary war materiel, we might be saluting the Nazi flag today.
Computers were added to lathes in the 1960s as they developed into the modern machining centers of today.
The most modern turning machines are computer controlled. You have originally spindle speeds of 3,000 to 4,000 RPM. Now you're talking 20 to 30,000 RPM.
Almost all the things that rely on motion from electric motors involve parts that spin, and most of those parts are produced on lathes and turning machines.
Lathes and boring machines did not develop in a vacuum. Other very different machine tools were developed at the same time. The second category, planers and shapers, at one time were some of the most important machine tools. Planers and shapers can be compared to the carpenter's plane, used to smooth and cut flat metal surfaces. With planers, the work moves under the tool. With shapers, the tool moves over the work. James Fox, a one-time country butler turned machinist, is credited with building one of the first metal planers in 1814. One of the oldest planers is at the American Precision Museum in Windsor, Vermont, home to one of the world's largest collection of machine tools. Ed Battison is its founder.
See the drama I've seen here, for instance. Most of the early machine tools have no maker's name on them. And they were made by the people that needed them rather than the people that were making a market out of selling them. We have an iron planer that's operated entirely by hand, and it was made with a file. It was cast to rough shape and then filed up. It would make all the shapes you can't make on a lathe.
James Naismith was an Englishman who worked for Henry Maudslay, the same Henry Maudslay who invented the first lathe. After Maudsley's death in 1831, Naismith moved to Edinburgh and opened his own shop. He specialized in making paddle wheels for steamboats, parts too large to move under a planer. So in 1839, he invented a tool that moved over the part. He called it a steam hammer. In fact, it was the first metal shaper.
This is a shaper from the American Tool Works, built in 1906 right here in Cincinnati. The shaper does a real basic type of job for people. It basically shapes a piece of stock. It goes through an enormous amount of movement just to perform this simple task, though. Shapers can eliminate simple filing. It can also make keyways or notches for fitted pieces. As the stock is moved left or right, the cutting tool is moved back and forth. When the cutting tool moves to the home position or to the rear, the table moves over gradually, and then the cutting tool moves forward again and takes another bite off of the stock itself.
Shapers and planers played a critical role, not just in creating new products, but in creating new machine tools. One of those tools was the milling machine, the third category of machine tools. Unlike previous machine tools, milling machines would not get their start in England, but in the newly independent United States. In the 1800s, E.M. Remington and Sons used their machine tools not only to make guns, but also to make typewriters. Machine tools will return on Modern Marvels. After the American Revolution, the British tried to maintain their industrial superiority by prohibiting machine tool exports to the United States.
After the Revolutionary War, a lot of the technology was banned from the United States in the same way that we have embargoes against Cuba, or people would like embargoes against China today. If the political situation had changed, then the technology would have come in, very freely.
We were the up-and-coming Yankees. England often looked down upon the United States in the types of machines that they produced, that they were inferior. They weren't of the quality of the British machines. And in some respects, that's very true. We didn't produce the types of these large, sturdy machine tools that the British did, but in many respects that worked in our favor, because the machine tool industry changed so rapidly in the 19th century that we could afford to build little cheaper machines. Within 10 to 20 years, they were on to something new and different, and those machines were replaced. Whereas I think many instances the British stayed with their old reliable machines, and we surpassed them.
Credit for inventing the milling machine is usually given to the famous American inventor Eli Whitney. But it's credit, some say, he doesn't deserve. Whitney was born in Westborough, Massachusetts in 1765 and became famous for his new cotton gin, used to remove the seeds from raw cotton plants. While Whitney held the cotton gin patent and the machines were legally his alone to make, the ease with which they could be copied made them the target of pirates. To cover his legal bills defending the cotton gin, Whitney started manufacturing rifles. He built the first milling machine to help fulfill a government contract calling for him to manufacture 10,000 muskets in a record-breaking 2 years. But some say the great Eli Whitney borrowed his design from another American gun manufacturer, John Hall. Government contracts said any machine tools used in gun manufacture could be copied by others, so long as they were used to help make more guns. Many believe Hall had the first milling machine and that Whitney simply borrowed his design. But being more famous, Whitney ended up with the credit.
I don't think they worried too much about whether somebody stole a patent or not, simply because communications aren't what they are today. I think that there was a tremendous amount of adaptation from one builder to another.
In many ways, milling machines do the work of a planer or shaper. Metal is cut smooth by a spinning blade. But unlike a planer or shaper, a milling machine does not have to back up after each cut, and that makes it faster.
The milling machine is pretty much the brains of the machine tool shop. It's used for making precise cuts. This one is a horizontal mill, or what's sometimes referred to as a slab mill. You can adjust the stock that you're working on any axis. This table is moving the stock against the rotating, sharpened steel tool. The steel tool basically chips away or scrapes away small particles of the metal. Any slab of metal that needed to be milled off to a uniform height would be milled on a horizontal mill like this.
The Cincinnati Screw and Tap Company built its first milling machine in 1878. The company would soon become the largest manufacturer of milling machines in the world.
A really big break for the company came just about the turn of the century with the advent of manufacturers of bicycles. And the bicycle parts, of course, are made of metal. And there was a need in the growing bicycle industry to have milling machines to make the components for bicycles.
Milling machines also became a key part of the early automotive industry, when Henry Ford used them in his factory to help manufacture the first Model Ts. Because the milling machine was more efficient than planers and shapers, By the mid-1900s, it had replaced them in most machine shops. World War I and World War II propelled milling machine manufacturers to make unprecedented numbers of these valuable machines.
The production of airplanes, or the production of jeeps, or the production of personnel carriers, or the production of tanks, or even the production of guns and arms, is all dependent on metal parts, mass-produced metal parts. In World War I, Cincinnati was very busy making basic machine tools, and we were making them for the factories that made war goods. In World War II, we were also extremely busy here and in making those same machine tools to support not just the U.S., but we were also supporting the Allies with machine tools during that period of time. And we were actually making components, portions of tanks, portions of personnel carriers. We were actually making those components in the factory at the same time we were making machine tools.
After the war, milling machines were retooled to make consumer goods, one of the reasons for the explosion in the standard of living in the 1950s. Within decades, milling machines had reached heights of precision and power never dreamed of before. Modern milling machines evolved into complete machining centers that could perform multiple functions on a part as it was milled.
The precision with which you can make metal parts that fit together in a tight fashion is solely dependent on the precision accuracy capabilities of the machine tool that you use to make those parts. The more accurate the machine tool is, the more precisely you can control the dimensions of parts that ultimately mate together in an engine or in an aircraft or whatever the case may be.
Precise, interchangeable parts are a concept we now take for granted. But prior to Whitney's milling machine, supposedly identical parts would always differ slightly. A machinist would have to shave the part for a match. Whitney claimed his milling machine was so precise that any part from any musket could be interchanged with any other. He called the concept interchangeable parts. Thomas Jefferson accepted Whitney's claims after examining 10 muskets, although some say Whitney overstated the interchangeability of his parts.
They were terrible. Jefferson was an enthusiastic amateur, but there's a lot of things he didn't know. And one thing he didn't know about was interchangeability. Whitney made one gun and 10 locks that supposedly would fit it. Well, that's easy enough to do if you spend time enough and money enough to do it, and he saved the contract that way. He fooled Jefferson and the War Department.
Nevertheless, the concept of interchangeable parts was here to stay. Soon, many gun manufacturers, including Robbins and Lawrence, Springfield, and Colt, had achieved it. While the milling machine brought about a new precision in the products it created, it didn't accomplish this feat alone. There were 4 other machine tools that played a critical role. Eli Whitney's milling machine was so well designed, it did not change for 150 years. Machine tools will return on Modern Marvels. Drilling is a very old art. The crudest form of drilling is the bow, a method familiar to most Boy Scouts. One of the earliest improvements in drilling was a bit with a twisted groove, so shavings would rise from the hole. The blacksmith's post drill was one of the earliest modern drills.
This is a post drill, and as with any tool, it eliminates a lot of work from your task. Instead of having to push down on a drill that you might have had to push down with your shoulder and get maybe an inaccurate hole, the post drill mounts firmly and securely on a post in the shop, and then the power is kept constant when you're turning it by the flywheel.
It was a simple step to connect the drill's flywheel to a steam-powered belt. Soon, power drills were in every machine shop. They became the 4th type of machine tool. For drills, advancement came not so much in the improvement of the machine, but in the metal that made the cutting bit. The early steel, made of iron and carbon, was hard, but it could be brittle. After crucible steel was invented in 1751, in which alloy steels could be created in a sealed furnace, drill bits could be made harder and were able to drill holes in harder metal stock. By the early 1900s, drilling machines were being used to build sewing machines, bicycles, and watches. Drills that could cut 30 or more holes at a time were used to machine engine blocks.
Hole making happens to be the most common metalworking operation in industry. We make a lot of holes. Drilling machines come in all kinds of sizes because we make small holes, we make very large holes. Hole making is just so common that it's essential to manufacturing in almost every industry. I think some of the most impressive drilling machines today are those designed for high-speed hole making. Typically, these drill at speeds that you can hardly see the hole making process. It's so fast. Certain workpieces require hundreds, even thousands of holes. So the faster those holes can be made, the more efficient the drilling machine has to
be. The advances of the 1800s that led to better drills also led to a new type of machine tool, the grinding machine. As early as the 1500s, Leonardo da Vinci was drawing sketches of primitive grinders. For hundreds of years, man has used forms of them to sharpen his tools. In 1837, James Naismith, the same Naismith who invented the shaper, patented the first machine grinder. Charles Norton was one of the most famous manufacturers of grinders. When his employers, Brown and Sharp, were not interested in developing a large production grinder, Norton set out on his own. In 1903, he developed the Norton grinding machine. It could grind out an automobile crankshaft in just 15 minutes, a job that previously took 5 hours. It was a tremendous success. Henry Ford ordered 35 for his Model T plant. Grinders are best suited to work on extremely hard metal. Once steel is machined, it is often heated and cooled in a process that can cause distortions. Grinders are one of the few tools that can machine this heat-treated steel.
Grinding is generally a process that's applied when extreme accuracy is very important, because grinding can be highly controlled and it can be used to achieve levels of precision that would be impossible with other types of machine tools.
Today, grinders are used by the aerospace industry to shape metals like titanium, Inconel, and Hastelloy, extremely hard metals designed to resist high temperatures. These modern grinders are the most accurate of all machine tools. The best can grind a part to within 1/10,000th of an inch. The sixth type of machine tool is the most simple, the power saw. The first steam-powered sawmill was built in London in 1663. It was built not to cut metal, but wood. It caused riots among woodcutters who thought the power saw would replace them. Not to worry, it took another century for steam-powered sawmills to reach widespread use. By the mid-1700s, as blades became harder, power saws were installed in most factories to saw metal before it was machined. In the early 19th century, the invention of a power bandsaw was made possible by the improved flexibility of steel. The saw's rotating blade was flexible enough to wrap around rotary wheels, yet hard enough to stay sharp.
Power saws are often the first machine tool that raw material is going to encounter, even though they may not have the same glamour that other types of machines have. They're still extremely important parts of the manufacturing process because they essentially create the workpieces that will go to other types of machine tools for complete manufacturing.
The seventh and final category of machine tool, the punch press, wasn't designed to cut or shave metal. It was made to press it into shape.
Metalworking is broken down into two different types. One, you have the production of parts by the removal of metal in the form of chips. And that's what we do on a lathe, on a milling machine, on a planer. But then beyond that, you have a form of metalworking, which is the forming of metal by pressure, so that you use a press then to form it against a die.
Punch presses were one of the final machine tools to be developed. They have heavy rams on a flywheel that, when triggered, press down against a base. They shape metal over a die, a hard metal block that forms the metal into a particular shape.
When I was young, my father wouldn't allow me to leave the car door open. I'd open the car for some reason and leave it hanging on the hinges. Nothing doing. That was a wooden body. And it didn't hold its shape, so you had to slam the door. But nowadays, you can let the door hang all you want to. It's all steel body. And as the volume of cars went up, they started making the parts in presses instead of in woodworking shops.
Again, machine tools played a major role in World War I and World War II, as punch presses formed parts for tanks, jeeps, ammunition casings, and countless other war products. Today, as punch presses have become more complex and precise, they are used to shape metal into every conceivable shape for every conceivable use. Next, the new ultra-modern machine tools. During World War II, the machine tool industry built 800,000 new machine tools. Machine tools will return on Modern Marvels. While machine tools remain as a legacy of the Industrial Revolution, since the 1960s they have taken on a new level of sophistication, rivaling their initial design. The most dramatic changes have to do with how they are controlled. The earliest machine tools used flywheels to control the position of the tool and the speed at which it cut. Beginning in the early 1950s, those flywheels came under the control of paper tapes and punch cards, used to trigger a precise numeric routine. That routine could be easily repeated. The process was called numeric control. Numeric control was invented in 1947 when John Parsons put a milling machine under the control of an IBM punch card. It spawned a whole new world of machine tools.
The biggest change in machine tools occurred with the introduction of numerical control. That basically made it possible to automate the entire machining operation. Instead of relying on the operator turning hand wheels, the motion of the machine is basically directed by the numbers that are read off a tape and then translated into corresponding motions that will duplicate the shape that the designer had in mind.
Everybody thought this was a great innovation where you had a paper tape that ran through a machine and you put your workpiece on. When machines became more automated, then they would have one man to set the machine up and an operator who simply put the workpiece in and push the buttons to start the machine, take the workpiece out, put another workpiece in, and there the responsibility was on the setup man.
Numeric control systems dramatically improved with the addition of computers in the 1960s.
That training and experience resides in the computer that controls the machine tool. And that's made it possible for the machine tool to do things that were simply impossible when they were operated by hand. We can do things that involve accuracies and shapes that would simply be beyond the capability of the machinist's ability to coordinate eye and hand to turn the wheels that move the workpiece or move the spinning tool against it.
Computer control means more fluid shapes can be made by the machine tools. One reason for the new modern fluidity seen in so many products. fluidity that first had to be created on a machine tool. Robots have also been added to machine tools to move parts and change tools.
The automatic tool change mechanisms are unique mostly to the machining centers. In the machining centers, they can utilize many tools, from a 40-tool magazine up to 400 and 500 tools in a magazine.
By definition, the cutting edge of a machine tool must be harder than what it is cutting. As metals get harder, machine tools have had to adopt ultra-modern cutting techniques. Many machine tools now use a process called electrical discharge machining, EDM. Powered by electricity, the machines use electrons to vaporize the material instead of cutting it with a tool.
They use the energy of a spark to essentially explode a microscopic bit of material away from the surface. This is microscopic, so it's something you can't see with the eye. But as that heat builds up to a certain point, it's at least as hot as the temperature of the sun, a small bubble of gas forms, and when that bubble of gas explodes, it blows away a microscopic bit of metal from the surface.
Like an electronic bandsaw, a microscopically thin wire charged with electricity cuts metal with a very fine edge. The cut is extremely smooth, eliminating the need for further machining. Some of the most modern machine tools being developed today don't work with metal at all. At Cincinnati Machine tools that are a combination of many different technologies are being used to create a brand new fiber material that's stronger than titanium, yet lighter than aluminum.
Basically, for 100 years, machine tool builders have been creating machines that take raw components such as cast iron, steel, or titanium, and by machining and cutting, we remove metal in order to create a finished part. This is the reverse process where we take the actual material, in this case fiber composite material, and we lay it and place it, building up the finished part for our customer. What I'll show you here is the actual fiber threads, fiber strands that are running through these 32 toes.
Multiple strands allow the fiber to be molded into smooth, fluid shapes. As it is laid down, the fiber is heated for fusing and cut to precise length. Holes are left for windows and other components. The new material is perfect for building lightweight new aircraft.
I think that in the next 10 years, we will still see the computer and communications technologies as the fundamental driver of innovation in the machine tool industry. It has been a driver for the last 20 years. We expect to see that knowledge start to become embodied in the machine tool itself. And it's the computer and the evolution of computer and motion control technology that's allowing that to happen.
From their earliest days in the small shops of London to the modern computer-controlled machining centers of today, machine tools have been at the center of man's industrial evolution. There is little doubt machine tools will continue to shape our future, just as machine tools undeniably shaped our past.